Why are ancient fault lines evidence of massive earthquakes? Imagine a giant crack in the Earth's crust that has been there for thousands or even millions of years. These cracks, called fault lines, are like scars left behind by huge earthquakes from the past. When tectonic plates move, they sometimes get stuck, building up stress over time. When that stress finally releases, it causes a big earthquake that can shift the ground in dramatic ways. These shifts leave behind physical signs that scientists can see today. One clear sign is fault scarps, which are steep ridges or cliffs formed when the ground suddenly moves vertically during an earthquake. These scarps can stick around for thousands or even millions of years. For example, the Tectonic fault in Canada shows fault scarps and landform offsets that are millions of years old. The landforms have been moved or displaced by hundreds of meters, showing the power of past seismic events. These physical features tell us that massive earthquakes happened long ago and shaped the landscape we see now. Another way we know ancient fault lines have experienced big earthquakes is through studying layers of sediment and rock. When an earthquake occurs, it can break or shift these layers. By digging trenches across faults, scientists find disrupted sediment layers that reveal when these earthquakes took place. In Salt Lake Valley, for example, researchers found sediment layers broken by earthquakes that happened tens of thousands of years ago. These findings prove that large seismic events have repeatedly shaken the area over time. Long periods of stress buildup along fault lines also point to the potential for future big earthquakes. Tectonic plates keep pushing against each other, creating strain. When the strain becomes too much, the fault slips suddenly, releasing a lot of energy. Ancient faults like the Tectonic fault have been quiet for a while but still hold a lot of built-up strain. This means they could produce another large earthquake someday, just like in the past. Cracks and fractures in the Earth's crust from ancient fault zones also show that these areas have been weakened over time. These zones are more likely to be reactivated under current stresses. For example, the New Madrid seismic zone is on an old fault system that was heavily deformed hundreds of millions of years ago. These zones of weakness can still produce large earthquakes today, even if they seem inactive now. Knowing about ancient fault lines helps us understand where big earthquakes might happen in the future. Sometimes these faults look quiet, but they can suddenly become active again after long periods of dormancy. Recognizing their history allows us to prepare better, plan for hazards, and build safer structures. It's like reading the Earth's history to see where the next big shake might come from.